All right, hello again. So, we're going to finish out this lesson with the idea of finding zeros. So, 8.2, finding zeros. Now, we spent a lot of time in chapter 7 factoring. That factoring is important for us, for it actually tells us where the zeros of the graphs we're working with presently in chapter 8 happen. Now, zeros, what they mean is, for instance, here it says find the zeros of the function. Well, the zeros are where the graph hits the x-axis. So in this case, we could look right at it. We could say, oh, you know what? I can see right there. It touches the x-axis at that position, and it touches it at this position over here. Now, what x position, I'll call this x1, and this one x2. What x position is the pink one? Well, it's at a value of -1. I'd have to go backwards 1 unit to touch it. So it's an x equals -1. What about the x2? Well, I can see from the graph right off that it touches at a value of 1, 2, 3. So it'd be an x value of 3. Now, this is not discussed necessarily in the 8.2, but I will say this for future reference that if you can see it from the graph, boom, you know where it is. As long as it crosses in a spot, you can tell. However, we do run into graphs where we can't quite tell, is it in the middle? Maybe it's in between, maybe it's only a quarter of the way. So there's got to be a better method than just looking at the graph itself. And we're going to discuss in just a moment how to see that. But what I want to point out is that the vertex will always be exactly between where it crosses the x-axis. So I see that the x-axis, the crossing, it happens 1, 2, 3, 4 units apart. So 4 divided by 2 is, well, 2. So I go 2 units over, and the vertex would be along that grid line. And of course, we can see that it is up there. Just kind of a side note for you. So again, you can find the zeros on the graph by just looking to see where it crosses the x-axis. However, what if it's not graphed for you? Well, then you have two options. The first option we'll consider right now is we will just go and graph this. We'll take some x coordinates. Let's just do like -2, -1, 0, 1, and 2. And let's plug them in. So I'm going to take -2, square it, and then -9, and see what I get. Actually, let's adjust this. I'm gonna skip. I'm gonna go from -3, then -1, then 0, then 1, then 3. I think that will be a much better picture for us. So I'm gonna plug in -3, square it, and -9. Well, you'll see why I now want to readjust the points. -3 squared is +9, and when I -9 from it, oh, that's 0. So I can say, okay, well, I would go backwards 1, 2, 3, and my output is a 0, so it's right there. Next one, I'm going to plug in -1 and square it, then -9. Well, -1 squared is, well, just 1, and 1 minus 9 is -8. So I'm going to go to -1 position, and I go down to -8, and it's down here. That's a blue, so it's right there. Now a 0. Plug in a 0 and square it in -9. 0 squared is still 0. -9 is, well, -9. So 0 means I don't go left or right. I'm still here in the middle, but I have to go down to 9. +1. +1 squared -9. Well, +1 squared is still 1, and 1 minus 9 is -8. So now I'm forward 1 and down 8. Last but not least, we will do 3, positive 3. Square it, minus 9. 3 squared is 9, minus 9 is 0. Okay, so I'm going to go over 3 and I don't go up or down at all. And so now I can see, once I've graphed it, where it crosses the x-axis. And I'd say, oh, okay, it crosses the x-axis, and I could label it as x1 equals negative 3, and x2 equals positive 3. I can see the two positions where it crosses the x-axis. Graphing is a great method, and we should do it if we have nothing else that we can think of to do. But there's got to be a more effective way, because I mentioned back here that what if it landed in between? And maybe we happen to have picked a number that we didn't actually see the zeros like this one. I happened to pick negative 3, which lined up right exactly. But what if it happened at negative 2? I didn't even choose that. I would have not known where it crossed the x-axis. What I'm getting at is there's another method, and it's one we actually already know. It says find the zeros of the function. Well, think about that idea of zeros. When do they happen? I'm going to go back up here. When does the zeros happen? When does it cross the x-axis? Well, it happens when the y value is 0. For instance, talk about this pink point. If I wrote its coordinate down, it's negative 1, 0. If I wrote down the blue point, it is 3, 0. Notice that I find where it intercepts the x-axis when y is 0. Again, this is the x, this is the y, this is the x, this is the y. I find it when y is 0. So down here, I say, oh, well, I can find my zeros if I first make the y a 0. Now, there are two methods. I will show you the factoring method because it is important. The factoring method. There's two methods to solve this, but I will show you the factoring method. Right now, all I have is an A and a C. What happens to my B? And we're used to 3 terms to factor. Well, generally, we know that ax squared plus bx plus c is how we kind of look for starting our factoring process. So if I don't have a b term, I, of course, can say I don't have a b term. So I have 0 x's to the first power, but I still have minus 9. You learned this, a times c and b. It needs to multiply to give us the top, and it needs to add to give us the bottom. Well, what is the a value on this? What's the a value? It's a 1. And the c value? Well, the c value is a negative 9. So 1 times negative 9 is negative 9. The b value is a 0. So what two numbers, when multiplied, give me negative 9, but if added instead, give me 0? Well, after a few minutes, you'd realize that it's negative 3 and positive 3. Negative 3 times positive 3 is indeed negative 9. But when added, they still make 0. So I can say, all right, well, it's x squared. And that doesn't matter which one we do first, whether we write negative 3 or positive 3, it doesn't matter. I'll write negative 3x, then positive 3x, then our minus 9. And hey, now this looks familiar. We say, oh, okay, what's in common with the first two terms? What's in common with the first two terms? Well, we would say, all right, I know that x squared is x times x, and I know that 3x is the same as 3 times x. What do they both have in common? Well, they both have an x. So that means there's an x on the outside. What did I not use? I did not use an x. The minus sign is still there. And I did not use the 3. I have a plus sign. The plus sign comes down. That stays there. What is in common with the second two terms? What's in common with the second two terms? Well, it's always good to expand this. 3x is the same as 3 times x, and 9 we know is 3 times 3. What do they both have? Well, they both have a 3 in common, so I'm going to take that out. And what did I not use? I did not use an x. The minus sign is still there, and I did not use the other 3. Did I get my parentheses the same? Yes, I did. Yay! That means that's 50% of my answer. What's the other? Well, it's what we factored out. So x plus 3. Now remember, all of this still equaled 0 because we're trying to find the zeros. So what would make this 0? Well, x plus 3 equals 0 when? Well, when x is a negative 3. What would make this other one, this second one, 0? Well, it would be when x minus 3 equals 0 happens when? Well, when x is 3, positive 3. Notice that this was the exact same problem that we just graphed up here, and we found the exact same answers when we factored it. Negative 3 and positive 3, negative 3 and positive 3. So factoring is a super important method for us to find zeros. We still need to do it in Chapter 8. I will end with one more. Again, zeros happen when y is 0. We can find where it crosses the x-axis when y has a value of 0. Now in this case, you've probably been taught to either factor out what they have in common or to do exactly what we did last time. 2x squared plus 0x's minus 8, and we go through the factoring again. A times c, the b on the bottom. A is this time is a 2, and c is a negative 8. 2 times negative 8 is a negative 16. We still have a 0 for the b on the bottom. So what times what gives us 16, or negative 16, but when added gives us 0? Well, after a minute or two of thinking, you'd realize, oh, it's negative 4 and positive 4. So that means I have 2x squared. Doesn't matter which one you write first. I guess I'll write plus 4 this time. So plus 4x, then the minus 4, really doesn't matter, and minus 8. What is in common with the first two terms? Well, if you're not sure, go back to that process we were just doing. 2 times x is the same as 2x squared. Plus sign's always there. 4 is the same as 2 times 2, and then 4x is the same as 2 times 2 times x. So what do they have in common? Well, I see a 2, and I see an x. Oops, and an x. There we go. So a 2x is what's pulled out. What did I not use? I did not use the x. I still have my plus sign, and I did not use a 2 from the second group. I have a minus sign. Please bring the minus sign down. Don't forget that. What's in common with the second 2? And I will highlight the second 2. What's in common with the second 2? Well, let's see. They both have, 4 is the same as 2 times 2, and then 4x, of course, is 2 times 2 times x. We have a minus sign. What's ways to make 8? Well, isn't it 2 times 2 times 2, I guess? 2 times 2 is 4, times 2 is 8. Notice I factored it as far as I could go. So now what do they have in common? Well, they have a 2 and a 2, so 2 2s. 2 times 2, so I have 2 2s. 2 times 2 is really 4, so really 4 was the number that was in common. And what did I not take? I did not take an x, and I did not take a 2. Now, why did I not put the minus sign immediately there? Well, because remember, a minus sign is out here. Negative 4 times, positive 2 will make the negative 8. Because if this was a negative, then it's a negative 4 times a negative 2, which is positive 8. That is not the same. So we got to be cautious. Hey, look at that. Parentheses are the same. That means x plus 2 is part of my answer, and 2x minus 4 is the other part of my answer. still equals 0. Now, depending on how much time you spent in chapter 7 and things you talked about, you could realize that there's a 2 in common and pull that out to the out front. But it doesn't really change where the 0 is. So, what once we factor it, we know where the zeros are. That means that 2x minus 4, what makes it 0? Well, if we add 4 to both sides, and then if we divide by 2. So x equals 2. So that is one of our zeros. What about the other one? Well, x plus 2 equals 0 when? Well, when we subtract 2 and we get x is a negative 2. Oh, there we go. So when x is a positive 2 position and a negative 2 position, it'll cross the x-axis. Let's confirm this real quick. I'm going to go to my graph. Equations. Let's graph it. 2x squared minus 8. Oh, there we go. Look at that. We can see it right there. It crosses the x-axis at negative 2 and positive 2. All right. So don't forget that you can find the zeros by either looking at the graph and seeing where it crosses, by graphing it yourself and hopefully see where it crosses, or, as we did in chapter 7, factor it. Thank you.